Hi, we're group B26. Our members are Austin Fite, Eleanor Rode, Genevieve Bell, and Zach Wahid. We're going to teach you about binomial theorem. We had some technical difficulties with this video, so it's kind of small. Bear with us. Also, this video and others can be found at www.knoatom.com.
So we're going to be talking about binomial theorem, and this theorem states that if we let x and y be variables and let n be a non-negative integer, then we can express the expansion of the binomial expression x plus y to the n as a summation of each of its terms, in which all of its terms have the coefficient of the combination n choose j. So as you can see, x plus y to the n would expand out as n choose 0 times x to the n plus n choose 1 times x to the n minus 1 y, and so forth until we find n choose n times y to the j. Might look confusing now, but it'll look much better when we go through this. So to find the coefficients of x plus y to the third, we know that the terms of the expansion are going to be x cubed, x squared y, xy squared, and y cubed. So in order to make x cubed, x must be chosen 3 times out of the possible 3 in the expansion. So as you can see, we choose x 3 times. So the combination 3 choose 3 is our coefficient for x, and it is 1. To find the rest of the coefficients, we'll see that x squared y, you only need to choose x out of 2 of the 3 expansions, leaving you 3 choose 2, which is 3. And so the coefficient for x squared y is going to be 3. Now, using that for the rest of the terms, we find that the expansion is x cubed plus 3x squared y plus 3xy squared plus y cubed.
So we're going to go over one of the corollaries to clarify and reinforce what binomial theorem and its binomial expansions look like. So the corollary 2 states that the sum of k equals 0 to n, the sum from k equals 0 to n of negative 1 to the k, and choose k, equals 0. So if you take the expanded form of the binomial theorem, you make x equal to negative 1 and y equal to 1, and then it looks like this when you write it all out: negative 1 plus 1 to the n. And then if you write it in binomial theorem, you have the sum from k equals 0 to n of negative 1 to the k, and then 1 to the n minus k. And 1 to anything is just itself. So you simplify that to the sum from k equals 0 to n of negative 1 to the k.
So for this example, we want to answer the question, what is the coefficient for x to the 7, y to the 12 in the expansion of 8x minus 2y to the 19? Using the binomial theorem, we have 8x minus 2y to the 19 is equal to the summation from j equals 0 to 19 of 19 choose j, 8x to the 19 minus j, times negative 2y to the j. Here the term we want is the term when j is equal to 12, which is 19 choose 12, 8x to the 7, negative 2y to the 12. When we factor out x to the 7, y to the 12, in order to get just the coefficient, we have 19 choose 12, 8 to the 7, times negative 2 to the 12, which is equal to this large number. And for our next example, we are asked to give a formula for the coefficient of x to the k in the expansion of x plus 1 over x to the 100, where k is an integer. Using the binomial theorem, we have the summation from j equals 0 to 100 of 100 choose j, x to the 100 minus j, times x to the negative 1 to the j is equal then to the summation from j equals 0 to 100. 100 choose j, x to the 100 minus 2j. Setting k then as the exponent 100 minus 2j, we find that j is equal to 50 minus k over 2. Then the x to the k term takes the form of 100 choose 50 minus k over 2, x to the k, which then gives us the coefficient 100 choose 50 minus k over 2.
All right, this brings us to example 4. For this example, we want to find the middle term in the expansion of the polynomial 4a minus b to the 8th. So there are 9 terms in the expansion because the power of the polynomial is 8. So the 5th term is the middle one. Using the binomial theorem, we see that the 5th term is in the expansion is the combination of 8 choose 4 times x to the 8 minus 4 times y, where x is equal to 4a and y is equal to negative b. So the 5th term in the expansion is combination 8 choose 4 times 4a to the 4th times negative b to the 4th, which equals 70 times 256 a to the 4th b to the 4th, which equals 17,920 a to the 4th b to the 4th. Alright. So for example 5, we want to express this long expansion in the form a plus b to the n. So we know that the first term is of the form a to the n because for whatever n is, the first term is the combination n choose 0, which equals 1, times a to the n times b to the 0, which equals 1. So 1296 times x to the 12th is equal to a to the n. By the same reasoning, the last term is b to the n. So 625 y to the 8th equals b to the n. And since the signs of each term alternate, we know that the binomial must be of the form a minus b to the n. So we know that for any power n, the expansion has n plus 1 terms. Since this expansion has 5 terms, n equals 4. So to find a and b, I only have to take the 4th root of the first and last terms of the expanded polynomial. So then a is equal to 1,296 x to the 12th to the 1/4. This is equal to 6x cubed, and b is equal to 625 y to the 8th. Oh, that's supposed to say 625 y to the 8th to the 1/4 power, and that equals 5y squared. So the expansion is equal to the binomial 6x cubed minus 5y squared to the 4th.
Thank you guys for listening. Once again, you can find this video and more at knoatom.com. That's knoatom.com. We're group B26. Our names are Austin, Zach, Eleanor, and
Genevieve.
You guys have a nice day. That's all, folks.